I'm Geoff Flarity. I'm an engineering manager on the Cache Cloud platform team. I'm responsible for all things Kubernetes and the cloud, and most recently managing the traffic team that owns Istio.
Hey, I'm Zantinge, and I'm a platform engineer on the Cache App Cloud platform team, and I work out of the traffic workstream, and I was responsible for rolling out Istio 2-hour clusters over the last year.
Okay, so can we start by giving people an overview of what Square's, or a high-level overview of what your infrastructure looks like, and to kind of set the picture of what we're dealing with?
Sure. So right now we're living in two worlds. We have a large monolith living in on-premise data center, and we're also breaking up that monolith and moving into the cloud. There's quite a number of things now running in the cloud. The cloud is built on top of AWS using EKS to manage it. Nothing too unusual, I don't think, about our deployment, but running Kubernetes, and we have now had Istio running in between services in the cloud and also helping with traffic from the DC to the cloud. I don't know, Jan, if you wanted to add anything else.
Yeah, so our architecture is a little bit, it's a bit strange. We have two service meshes. One is managed by Square and one is managed by us, which is Istio. And so we have had to work around managing the transition between those two service meshes. So that's one of the main interesting problems and interesting quirks of our architecture.
Okay, so you mentioned just there that you had a in-house service mesh. Why? Can you talk about some of the limitations and maybe why you looked to Istio?
Yeah, so the main advantages of that in-house service mesh are really that we have some, on-premise, pardon the pun, expertise to help us and actually own the code base. But more and more, the cloud platform team is looking to leverage open source stuff and moving away from our own kind of custom made stuff. It isn't scalable. It's hard to get enough eyes and enough coders in to make that product better. And so we've kind of gone all in on Kubernetes in general. And so we were really looking for a Kubernetes first cloud native service mesh to deploy and moving away from, our own custom built stuff.
Thanks, John.
And I have nothing to add there. Yeah, that's basically agreeing with what Geoff said. Our Square Envoy service mesh is, it's very proprietary, and it uses a lot of stuff that Square has developed for other purposes, like for DNS and stuff like that. And Kubernetes, we'd like to have something that's native for that. So Istio was a natural fit for us.
Okay, so you're interested in kind of Kubernetes functionality, presumably. If you're dealing with finance, you're obviously interested in TLS. What other features did you leverage with Istio?
Well, I think we wanted to leverage all the traffic shaping features in Istio, really. We wanted to use things like circuit breaking, having support for different load balancing algorithms and stuff like that. But I think with our initial rollout, what we wanted to do is just get ourselves in a place where we could start using those, not necessarily decided on which ones we want to use yet, but know that there's this entire toolkit at our disposal that we can take advantage of. And so that's what our goal was with the rollout. And since the rollout happened, we have actually been able to take advantage of a number of these things, a number of these features, due to production outages or feature requests from product engineering, whatever have you. So yeah, that's gone really well, and that's why we kind of did our Istio deployment. Jan, did you have anything else you want to add?
Yeah, I mean, when we started this whole project, we had a few objectives, like Geoff said, and we had a few features we wanted to maintain, and then a few features we wanted to to make use of, right? And so we had a problem with long-lived connections going from the DC to the cloud, and so that's the thing we wanted to resolve immediately with the deployment of Istio. We also wanted to simplify certificate management. It was a bit of a manual process to get Square certs, Square signed certificates from Square. And so we wanted to sort of automate that a bit with Istio's ability to issue certs to workloads. And those were the immediate benefits. And then, yeah, like Geoff said, we had a bunch of ideas for things we wanted to do in the future as well.
Okay, so that's mostly why. Let's discuss a bit about how. And a reminder, if you have any questions, ask in the IstioCon Slack channel, and I'll ask them on your behalf. So can you talk through kind of the adoption strategy you took? So obviously, Geoff, more from an organizational perspective, and yeah, or from a technical perspective?
Yeah, I mean, I don't think I'll have too much to say here other than from my perspective, what was most important is that we had a clear just role plan in terms of like how we were going to phase in the Istio service mesh and that we could do it incrementally. And that's what ended up happening and went pretty well and seemed easy from my perspective as the pointy-headed boss. But I'll let Jan go into actual details there. I know it was a lot of work.
Yeah, for sure. So like, I think our strategy started off with just simply trying to understand what Istio was and how we could use it and like understand the concepts behind it. And like, you know, Istio can be kind of overwhelming at first, but once you get the hang of it, it becomes very intuitive and easy to understand. The next thing we wanted to do, me and my colleague, is we wanted to outline the goals, as I mentioned before. So we wanted to simplify certificate management. We wanted to like handle long-lived connections to enable HTTP2 and gRPC and that kind of stuff. And we wanted to maintain a few things we already had, which is like MTLS connection encryption for all connections, and so on and so forth, right? So then the next thing that we did was we wanted to set up a POC, like a proof of concept, right? And so we created an environment for ourselves that was connected to our DC and would allow us to like set up all of these different routes that traffic would take in our situation, specifically going from the DC to the cloud, and then from the cloud to the DC, and then within a cluster itself, and then between two clusters, because we have redundancy across regions. So we have a cluster in East and a cluster in West, and we just want to make sure that we can still send traffic across those boundaries, right? And then the next thing we wanted to do after we set up that POCs, we wanted to design, exactly how we wanted these things to flow. And there were a few quirks that we had to work around. As I mentioned earlier, there is a Square managed service mesh, and that actually was already kind of deployed in our cloud clusters. Each service would have had a Square Envoy sidecar, or Square managed Envoy sidecar that allowed communication to the DC. And we had to make a few compromises in order to make sure that we could roll this out fairly quickly. And so we kind of left that hanging around. We allowed it to still communicate with our DC and ensured that Istio proxy wouldn't capture traffic to it or capture traffic being sent from it to the DC. And then we also wanted to ensure that traffic coming from the DC and coming from elsewhere in the cluster using our legacy route, which our legacy route consisted of a load balancer for each service. And then a service would talk to a name, and then it would that load balancer or that name would resolve to the load balancer, and then the load balancer would forward the request to the actual service in Kubernetes. And so we wanted to make sure that still worked. And so the quirk there that we decided upon is we wanted to create an ingress gateway for each service. And I think I might actually have a diagram for that. Let's see. Whoops, hold on. So we're going to go over here. This guy here. Yeah, so this is the design we decided on to handle traffic going to legacy endpoints. And so this one involves the Square DC specifically, but it actually holds true for our in-mesh stuff too. And so we set up an ingress gateway, an Istio ingress gateway per service that would then use the certs that we previously provisioned for the Square service mesh and for Square in general, the Square certs I mentioned earlier. And it would basically open a port that would listen for MTLS connections using those Square certs and then translate the MTLS, the Square MTLS requests into the Istio service mesh requests and then forward them on. This did a couple of things for us. First, it allowed us to maintain backwards compatibility, so we could migrate each service one by one. And then on top of that, it also shifted the issue of long-lived connections and like hot pods to the ingress gateway instead. And so our services had some issues, handling long-lived connections, and that would cause certain pods to be overused more than others. And Envoy, we deemed better suited to be able to handle that kind of thing. So yeah, we implemented these designs in their proof of concept. And then the thing we did after that, once we actually had a working proof of concept and we had a final design doc, is we started to create a process for migrating services onto and off of the mesh. And I emphasize off of the mesh because you really want to be able to roll back things very quickly if something happens to go wrong. And so we wrote essentially scripts, I guess, in a CLI application that we deployed to everybody, and that allowed us to simply run a command that would bring a service onto the mesh in an automated way. We could then watch for any issues that came along with it, and then if there was something wrong, we could quickly take it back off the mesh and like leave it as it was. And so at a high level, that was basically our strategy, and I think it worked fairly well for us. We didn't have too many issues getting stuff onto the mesh, and like our backwards compatibility enabled us to do that in a very invisible way, which I think worked out very well.
Yeah, I'm familiar with that. Typically what happens when something breaks is the first thing that gets blamed is the service mesh. The second thing that gets blamed is Kubernetes. The first thing is the service mesh.
For sure.
So I generally think of this in kind of 2 dimensions, right? So you have one dimension you mentioned of, incrementally adopting services into the mesh. And the other dimension I kind of think of is features. So did you have like a certain subset of minimum features that you adopted everyone on? Did you kind of do that? Did you do like just a one-dimensional one, or did you do kind of like a piecemeal thing? How did you go about doing that?
So,
sorry, did you mean the features of Istio that we wanted to start taking advantage of? Yeah. I mean, from my perspective, I think since we were already kind of like running our own in-house service mesh in the DC, there was that subset of features that we wanted to maintain and take advantage of with Istio. And I think that we've been more looking at expanding the set after we kind of came on with that like parity, if you will. But Jen, did you say that's accurate or?
Yeah, for sure. Like I did kind of mention this a little bit earlier. We did have some things we wanted to maintain, like just MTLS between services, but mostly with this initial migration, we wanted to make sure that everything was working the way it did before the service mesh, so that we could start making use of newer features later, and we would like, drop designs for some of the things we want to do in the future. So yeah, I think that was really, we didn't really look to do too many new things right off the bat. We wanted to make the migration as smooth as possible. So
I will say though that like once we had it up and running, features that we maybe had on our roadmap got put to the forefront based on different production issues that we saw. I know circuit breaking is one of the ones we were like always planning to like roll out, but suddenly that became very urgent and it got moved up, and that went incredibly well, all things considering. So yeah, I think that kind of summarizes things pretty well.
Okay, so how do your application teams interact with Istio day to day? Are they, some of them aware that it exists? Do they like, is it completely abstracted away from them? What does that look like?
We try to at least raise awareness about the existence of Istio and like the features that it's providing the product engineers who we consider our customers. That being said, I think that the product engineers are very focused on building their product and shipping their features. And they're really just kind of looking to us to provide them with guidance and consultancy and like tooling, most specifically tooling, self-service tooling that just kind of like makes it all work. And they don't have to think too much about. So it's fairly abstracted away from our customers, but the glass, we can break the glass if we have a particular customer that's, very cloud native aware. That's an option, but for the most part, people are content to just kind of use our abstractions.
Yeah, for sure. I think, to be honest, a lot of our service owners don't necessarily think about Istio too much. I think we've discussed whether we want it to be that way or not. We try to advertise it, but I think most people, like Geoff said, don't really care too much. We did try to deploy sane defaults for a lot of things. So like people could still do things like fail over their service to the backup region if they needed to, and that would just go through Istio instead of what we were doing before. But there is going to be movement towards providing them a sort of manifest that they can use for traffic configuration. We have currently an in-house thing for translating an HCL manifest into like a Helm chart or something like that. And so we are already in the process of creating for our service owners a subset of configuration for traffic that they can use. Things like circuit breaking, providing values for them so that they can have a destination rule created for their service so that their pods don't get overloaded if that happens, right? And then on top of that, to be able to handle something like internet ingress and allowing them to specify which of the endpoints they want in their service to be accessible to the public internet. So like that's the kind of stuff that we're going to move towards over the next few months, I'd say. And that's the kind of control we want to give them, just like an abstracted level of control that gives them only the values that they actually care about, and maybe not all the other stuff that could be a bit confusing to those who don't have the time to spend understanding Istio. So,
yeah.
Okay. What advice would you give to someone who's now about to start off their Istio adoption, and are there any kind of gotchas that you should be aware of?
Yeah, so I think the advice I would give them is to they can always reach out in the channel and ask us and chat with us. We're happy to talk and interact with people. But barring that, I think that just having a rollout plan that also incorporates rolling back and having it be kind of per service rollout was the secret sauce from a manager's perspective, because there were little things that kind of happened, and because we were able to roll them back instantly, there was never an issue, and it was just part of the iterative rollout process, and it felt very positive. So I think that's the main thing from my perspective. I think in terms of gotchas, I think I'll let Jan talk a little bit about the fun with Unix domain sockets. I think that the high level there is that Unix domain socket support isn't always amazing depending on what platform you're trying to incorporate, and I'm thinking Java in particular, or JVM. Jan, did you want to go into some issues there?
Yeah, I agree with what Geoff said. I think he pointed out that having a very easy migration strategy is very important, and I emphasized that earlier. That was extremely beneficial to us. And as long as that's codified and easy to execute, it can make the whole process of migrating a lot easier and a lot less stressful. Specifically, I think I would, when I first got onto, looking at Istio and trying to understand it, it always felt a little bit overwhelming, but just sticking with it, it becomes very easy to understand, and you just got to figure out which bits of configuration apply to which, which pieces of the mesh. And I think once we got past that, it was pretty easy to understand. But yeah, more specifically, the technical issues surrounding Unix domain socket support, we ran into a few issues, not just with Java and a few of the platform-specific things, but we did have a few issues with Istio as well. I know Istio 1.5 had a bug in it that prevented the sidecar configuration from properly specifying an ingress or any Unix domain socket really for use by a service, or sorry, for an Istio proxy to interact with. And then, going back to the Java thing, we ran into some issues with Jetty and some weird headers that had some strange characters in it, and that could cause Jetty to have some issues too. And so we've had to work around a few of these things here and there. But otherwise, I think the Unix domain socket support in Istio specifically is vastly improved over the last year, and I haven't seen any real issues with it. We did recently have an issue upgrading from Istio 1.7 to Istio 1.8, but that did eventually get fixed, and so that's it's very encouraging that this is getting better. But like I said, the Java stuff is not necessarily getting better, so sometimes you'll have to find ways to work around these things, and Istio does provide that kind of stuff. So maybe the best piece of advice around Unix domain sockets is maybe just to avoid them for now, depending on your platform. But I didn't really mention why we use them. We kind of consider them a security boon, and then also, there is the assumed performance benefit that you get from it as well. I think both of those things probably weren't didn't have as big of an impact on us as we might have initially thought, and so we probably could have saved ourselves a bit of grief early on and just done that migration later. But I'm glad we're done it now, so it's cool.
Yeah, I think one last thing I'd add in the gotchas that we encountered was the love of long-lived connections was kind of a reoccurring theme. And I don't think that was necessarily Istio-centric, because I think any load balancer that auto-scales would have kind of caused a problem. But one thing to be aware of is if you have clients in your, I forget if it's downstream or upstream, but you have clients calling into the mesh and they like long-lived connections, you might want to investigate the Istio options around having a time to live for connections so that scaling works as you would expect.
Yeah. Okay, so we have a question from Stefan. He's asking, what do you do to build confidence in service mesh? Do you have automated testing, chaos testing? Can you kind of talk about that?
Yeah, I mean, so I think that we were coming from a place where on-prem we were already using Envoy, and so like when you think about Istio, you should think about it's using Envoy, and it's a control plane for Envoy that's Kubernetes and cloud native, and so like we were already sold on the cloud native part, and we were already sold on the Envoy part, completely separately of this project. So for us, it was more about just like coming out with a rollout strategy that we could have confidence in, and then testing it. So like testing it in staging environments, testing it, and we have our own platform testing environment that we rolled it out on ahead of time, taking the time to do it right. From then on, like, we don't have anything particular. We have all the probably common alerts around RPC connections dropping unexpectedly and stuff like that. Too many 5.0 whatevers, but there isn't a ton of like chaos testing or anything, because we already had a lot of confidence in Envoy's ability, and Istio impressed us from the start. So, Jan, do you have anything to add there? Did anything like, were you concerned about rolling out Istio, and is there something you needed to do to build confidence?
Yeah, so I mean, we did a couple things, right? So the most obvious thing was to have smoke tests sort of going all the time. And we have a couple services that we call the stooges that are running in all of our clusters and running the DC. And so we have these things running all the time, and they just kind of verify that the routes between all of these clusters are working properly and even within the cluster. And so that can give us an idea if Istio is causing some issues our way. It's actually the thing that helped me figure out that the upgrade from 1.7 to 1.8 was causing some gigantic issues in our platform staging environment. And on top of that, while we were like rolling this out or getting ready to roll this out, we did some stress testing just with some like test services within the mesh and like across clusters as well, just to verify that like, the performance was what we expected, that we had the proper resource requests for Envoy and for IstioD and that kind of stuff. And that's what allowed us to build confidence that this would actually properly scale up and handle like increased load, increased traffic flow as well. So, yep.
Okay. So that is time. If anyone has any more questions, we'll be in the IstioCon Slack channel answering. I will mention that both Square and Tetrate are hiring. So if you're interested in jobs, ping either Geoff, Jan, or myself, depending on which company you're interested in. And yeah, thanks for your time, guys.
Yep. Feel free to reach out to us in the channel.
Thank you.